Welcome everyone to the What Happens When channel, where everyday questions are answered. Before we get into it, why don't you hit the subscribe, like, and smash the notification bell? Okay, let's do this. Welcome to today's fascinating exploration of one of nature's most intriguing hypothetical scenarios. What would happen if two of Earth's most powerful atmospheric phenomena, a tornado and a hurricane, were to meet? Before we dive into this meteorological mystery, take a moment to hit that like button and get ready for an incredible journey into the science of storms. The very concept of a tornado meeting a hurricane might sound like something from a disaster movie, but understanding this interaction helps us grasp the complexities of our atmosphere. Tornadoes and hurricanes are fundamentally different beasts, each with their own unique characteristics and behaviors that make their potential interaction both fascinating and complex. Let's first understand what we're dealing with. Hurricanes are massive tropical cyclones that can span hundreds of miles, with wind speeds reaching up to 157 miles per hour or more. These weather giants are powered by warm ocean waters and can persist for days or even weeks. Tornadoes, on the other hand, are much smaller, but incredibly intense rotating columns of air that typically last for just minutes, though their wind speeds can exceed 300 miles per hour in extreme cases. When these two atmospheric titans encounter each other, the result isn't as simple as you might think. The interaction between a tornado and a hurricane involves complex atmospheric dynamics that scientists have studied through both historical observations and advanced computer modeling. Interestingly, hurricanes actually create conditions that can spawn tornadoes, particularly in their outer rain bands and especially in the right front quadrant of the storm. The science behind this interaction reveals fascinating details about atmospheric physics. When a hurricane makes landfall, it often creates perfect conditions for tornado formation. The wind shear, the change in wind speed and direction with height, combined with the unstable air mass can trigger tornado development. However, if an existing tornado were to encounter the main circulation of a hurricane, the larger storm's wind field would likely dominate and disrupt the tornado's rotation. Think of it like this. If you were to pour a small cup of water into a large, swirling pool, the smaller circulation would quickly be absorbed and lose its distinct identity. Similarly, a tornado's relatively small and intense circulation would typically be overwhelmed by the hurricane's much larger wind field. The tornado's rotation would likely be distorted and eventually absorbed into the hurricane's broader circulation pattern. Historical data supports this understanding. During Hurricane Andrew in 1992, multiple tornadoes were observed forming within the hurricane's structure, but none maintained their independence when encountering the storm's main circulation. The same pattern has been observed in other major hurricanes, where tornadoes form in the outer bands, but are ultimately dominated by the larger storm system. The interaction also demonstrates fascinating principles of energy transfer and conservation. While both storms are powered by atmospheric instability and temperature differences, their scales of operation are vastly different. A hurricane draws its energy from warm ocean waters over a vast area, while a tornado derives its power from more localized atmospheric conditions. When these energy systems interact, the larger system typically absorbs and redistributes the energy of the smaller one. Climate scientists use sophisticated computer models to study these interactions, helping us better understand and predict severe weather patterns. These models have shown that while the immediate collision of a tornado and hurricane would be spectacular, it would be relatively brief. The hurricane's massive wind field would quickly distort and absorb the tornado's rotation, incorporating its energy into the larger system. This phenomenon reflects a broader principle in nature. When systems of drastically different scales interact, the larger system often dominates. However, this doesn't mean the smaller system's energy simply disappears. Instead, it's transformed and redistributed within the larger system, potentially contributing to local intensification of the hurricane's winds or rainfall in specific areas. Understanding these interactions has practical implications for weather forecasting and public safety. When hurricanes make landfall, emergency managers must be prepared not just for the hurricane's direct effects, but also for the possibility of tornado formation. This knowledge helps in developing more effective warning systems and evacuation procedures. As we conclude this exploration of atmospheric dynamics, we're reminded of nature's incredible complexity and the importance of continuing to study and understand these powerful weather phenomena. The interaction between tornadoes and hurricanes demonstrates how seemingly straightforward questions can lead us to discover fascinating insights about our atmosphere's behavior. What are your thoughts on this meteorological mashup? Have you ever experienced either a tornado or a hurricane? Share your experiences and theories in the comments below. And don't forget to subscribe for more exciting explorations of nature's most powerful phenomena. Together, we can unravel the mysteries of our amazing planet's weather systems and better understand the forces that shape our world. Thanks for watching.